Hello everyone, in this video we're going to be solving a homemade differential equation. We have y double prime equals y prime divided by square root of y. And we're going to be solving for y. Alright, great. So we can look at this problem from two different angles. So let's look at the first method first. So I want to treat each side as the derivative of something. So what is y double prime? Y double prime is the second derivative, which can also be written as d squared y over dx squared. And y prime can be written as dy over dx, right? Great. So how do we treat y double prime? It's basically the derivative of the first derivative, right? Okay, that's good for the left-hand side. But what about the right-hand side? Can y prime over square root of y be written as the derivative of something? Let's see. First of all, remember the derivative of square root of x. I hope you do. It's 1 over 2 times the square root of x. What about the square root of y? What's the derivative of that, right? Well, it's going to be pretty much the same thing, except for the chain rule is going to come in. And the derivative of the inside, which is y prime, you just have to multiply by that. Because the derivative of x with respect to x is 1, we don't have to write it, right? I mean, we just write 1, in other words. So does that look familiar? Take a look at this and take a look at that. What does that look like? Well, it would be nice if we had a 2 at the bottom, but don't worry, we can make it happen, right? Just put a 2 in the numerator and denominator. So now, since 2 is a constant, we can exclude it and put that outside and write the inside as the derivative of square root of y. Make sense? Right? Hopefully. Okay, great. So from here, we can hopefully get to something meaningful. And the reason why I took the 2 out is because it's a constant. Whether you integrate or differentiate, doesn't matter. It's just a product, a constant product, right? Or a coefficient, whatever. So now we have a simpler case, right? Because the derivative of something equals the derivative of something else. By the way, I could also write the 2 inside. It would not make any difference. Make sense? Okay. Great. Now what do? We want to remove the derivatives on the outside, so we need to integrate. But when we integrate, we need to bring in a constant, right? So we have to be careful. So I'm going to be using a lot of constants, so let's start with c sub 1 and c sub 2, c3, whatever, so on and so forth, because at the end, we kind of need to simplify the process, okay? So if you integrate, you're going to get y prime equals 2 times the square root of y plus a constant. Let's start with c1. All right? Cool. Now, obviously, y prime is the derivative of something, and we need to integrate one more time. But we don't have a function of x on the right-hand side, so here's what we need to do. Write the y prime as dy over dx, and then you just need to switch some terms so that you can get a separable equation, and this is what we're going to get. And at this point, since the variables are separated, we can go ahead and integrate both sides, right? So we use integration twice, but here it's kind of easy because both sides are the derivative of something. Make sense? So you can basically just remove the derivative symbol or the prime, whatever, and that'll be a little easier. Here, we kind of have to think differently because we have the integral of 1 over 2 times the square root of y plus a constant, right? How do you integrate something like this? Well, we probably need to do this. Use u. I mean, u substitution or some other substitution. I'm probably going to need to use u later. Let me see. Well, I guess I can use it. No worries. Let's go ahead and do this. I want to replace this with u, but I have a couple different choices. Actually, 3 choices. I can call this u, I can call this u, or I can call this u. Which one should I do? I want to go with the whole thing because that seems easier. So let's go ahead and call the whole thing u. And then from here, obviously, my goal is to get to dy. So let's isolate the radical and then square both sides. That's going to give me 4y equals u squared minus 2c1u plus c1 squared. By the way, c1 squared is another constant because c1 is a constant. Make sense? And then you can divide both sides by 4, no big deal, or just d both sides. Differentiate, but without the dx. Make sense? So let's do it. This is going to be 4 dy. And now on the right-hand side, everything you have to write in terms of du. So it's going to be like this. 2u, happy birthday, by the way, it's your birthday. Happy birthday to you. Anyways, if you differentiate this, that's going to be minus 2c1, because you're differentiating with respect to x, right? Use a function. Plus, okay, don't do 2c1 because c is not a variable, or c sub 1 is not a variable. It's a constant. So the derivative of the constant is 0, big fat 0. Okay. Now, what should you do next? Of course, don't forget to multiply by du. That's the important part. Now, we have a nice equation that we can plug in. But we have a fourth, so we're just going to multiply by 1/4. So dy is going to be 1/2 u minus c sub 1 du. You get the idea? 2/4 is 1/2. Let's go ahead and plug it in. I'll put the 1/2 all the way on the outside. U minus c1 du. That's for the numerator. And the denominator is going to be u. That's the cool thing about it, because the whole thing collapses, right, easily. So I think this is a better choice, in my opinion. Now we can go ahead and separate this into two pieces. U over u is 1, and this is c1 over u, and then du. Of course, at the end, I have to multiply everything by 1/2. Now, how do you integrate 1 with respect to u? It's just u, right? 1 du is u integrated. And c1 over u, 1 over u is ln, so we're going to write this as ln u, right? And then, of course, I have to put the 1/2. I'm not using the I'm not using a constant yet, because I do have another integral on the right-hand side. That's where I'm going to use it. The integral of dx is easy. That's x plus a constant. Let's use x plus c2, because c1 was already used. By the way, I don't know how, but I made the c1 disappear. It should be there. Okay, cool. Now we have this expression, which is nice because we got rid of all the derivatives. Now we're closer to the solution. But what is u? U is this whole thing, remember? So we have to back substitute. Let's do it. 2 times the square root of y minus plus c1, sorry, that's the u, and then minus c1, right? That was c1, and this is c1 again, I think, same constant, times ln u, and u is 2 times the square root of y plus c. Awesome. And then the whole thing is multiplied by 1/2, and then that's equal to x plus c2. Great. Y and x, good, so we're in good shape. You can go ahead and distribute the 1/2 if you want, no big deal, or you can leave it like this. But the million-dollar question is the following. Obviously, at this point, if you want to stick to this, right, and work with that, because I'm going to show you something from Wolfram Alpha, which is pretty interesting. But first, I have to show you the second method real quick, okay? Ready? Now, I'm going to approach this problem slightly differently. Maybe we're not going to complete this because I don't want to make it too long. I'll show you the idea and you can finish the rest. I want to put these derivatives on the same side and do the same thing. Isolate the y, or the square root of y. And then, of course, I do have, magically, I just added a 2 there, right? Okay. I just multiply the top and the bottom by 2. And now we have the derivative of something. But what about the left-hand side? Again, that is the derivative of something. You know what that is? It is ln y prime differentiated. Why? Because if you differentiate ln u, it becomes u prime over u. But y double prime is the derivative of y prime, so it just fits the pattern. There you go. And then we have the derivative of square root of y, but there's no y prime. That's the problem. How can I deal with that, right? So that's kind of problematic. And I don't think this is going to get us anywhere, but I was hoping that it would. Anyways, so this didn't work. I just tried at least. Now, if you go back here, what can I do? I have u minus something ln u. Think about it. And then now that we're going to look at the result from Wolfram Alpha, hopefully that'll make more sense. Uh-oh. Wolfram Alpha isolated y because it can. Come on. It's AI, right? It's a machine. It's programming. And what it did was Lambert's W function. Think about where that comes from. And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.